Hello and welcome back to the second episode of the Flint tutorial. Today we will learn how to draw something to the screen. Then I'll show you how to hot swap code, which means changing code on the fly. This only works in certain situations, but it's very useful when it does. And then lastly we'll make a simple feature that can read the CPU usage of a plot and display it in the top left instead of, or the top right, instead of displaying it in the action bar. Let's get started by learning how to draw something on the screen. For that we will need a new feature. So let's make one and let's call it Legs Layer Display feature. This will be implementing the rendered feature. That means that when we hover over this and implement the method, we'll get a function here that runs on render. This we can rename to draw because it's easier. And what we want to do for now is we just want to draw a text with shadow. And this will need a text renderer. For that you can just do flint.getClient.textRenderer. Then this needs a text, which we can just do text.literal high. And then we need positions. So for now let's just go with 100, 100, so that it's somewhere in the center of the screen. Now let's go with 300, 100. And for the color we always just go with white, because if we want any color formatting, we'll change this text here. Let's now run this, but before we run this, we need to actually register this feature. So let's go into here, let's copy this, and let's do new Legs Layer Display feature. Now as you can see, this is a lot of duplicate code. I don't like this. So what we can do instead is we can call register features, take this and put it in here, and now they're both in one method call. And you can just separate them by comma. Now, let's run this, but let's not run this with the run button. Let's run it with the debug button. This is useful because when you run it in the debug mode, hot swapping is an option. That means that we can in a second change these values here. We can do a lot of stuff in hot swapping. Some stuff isn't possible, like creating new global fields or stuff. But a lot of stuff is possible. So let's join DiamondFire. And let's wait for the title bar to disappear. Let's make the window a little bigger. And as you can see, this says hi. Now, we want to change this to render in the top right corner, right? So let's clean this method a little up. Let's make a text equal text.literal high, but let's not put this out here, let's put this in here for now. So this will be the text to display. So instead of putting that here, we just put text. And then we want to have a int x equal 300 and a int y equal 100. The color we can just leave right there. And now let's think about this. So we want this to be at the very right. To explain how rendering works real quick. In a Minecraft render screen, this is 0, 0. When you want to go to the right, you go plus on the x-axis, and if you want to go down, you go plus on the y-axis. This means that we want to go the entire width of the window to right here, and we don't want to change the y. So that means we want y to be 0. We want x to be flint.getClient.getWindow.getScaledWidth. Now we can, let's have this right here, let's click code changed. Let's wait a moment. It should build some stuff. And you see it's gone now. That's because it's right up here, it's right outside of the window. That's because we're rendering it above the window and to the right of the window. To fix that, for the x, let's deduct the text renderer that we had, flint.getClient. Let's put this into a variable too, actually. That makes it easier. Text renderer equals, not this, equals flint.getClient.textRenderer. So now we can just write text renderer here. And here we can do the window width minus text renderer.getWidth of the text. that means that it will shift it to the left by the size of the text. And for the y, let's do 0 plus the text renderer dot font height. And 0 plus, we can just remove the 0. This will just be the font height. Now, let's refactor again. And you see, it's now theoretically here. We didn't actually need this y. Y can still be 0. That was my bad. But now it's up there in the very corner. We don't want that though. That looks ugly. We want some slight padding. So let's add 3 here. And let's add 3 here. Let's deduct 3 here, of course. And now it's slightly away from the corners. If we now put a bigger text like hello world, it will also fit there. That's because we included the width of the text in our calculation for the x position. Now this is great, but what we want to do, and for this we actually do need to restart, what we want to do is we want to get, let's go into a plot real quick, we want to get the CPU usage. This is usually displayed like this in the action bar. Now we don't have these characters, and we could now look in this menu for them, or we could look online for them. But what's much easier is we can just print it out. So let's close Minecraft. And now let's make this class implement another thing. Let's make it implement the packet listening feature. And now we want to listen to packets, right? So let's go to onReceivePacket. And this will run when we receive any packet at all. But what we want to specifically check for is if the, well, let's showcase how to find what a packet is. So what we can do is we can just system out println packet.getClass.getName. Now this will send a lot of messages, but let's start Minecraft. Oh, let's return, and in this case we need to return an event result. We can either cancel the packet, which means that it won't be received by our client, or we can just do nothing, which is what we want to do for now. We want to pass. So let's do that, and let's run Minecraft in debug mode again. And now it will print in chat every packet that gets sent to us. This means that we can find what packet is the one that we need to worry about, right? So as to not get packet spammed, let's set our simulation and render distance down. And let me real quick just set up my controls, okay. So you see there's a lot of packets now. So let's go into a plot. And once it's done doing chunk data, we can do /play. There's going to be some more chunk data. And now it sends overlay message S2C packets. That's likely the one that we need. So let's do if packet is an instance of a overlay message S2C packet. Now we can do something fancy here with the Java language. We can put in brackets and do text the text. This will set the variable text in the scope to the text that is getting sent. So let's invert this if check real quick. So if it's not an overlay message packet, let's just return event result.pass. And let's move this system out println, and let's change this. Instead of printing this, let's print the text.getString. Not toString, getString. This will print the text that we get sent, but without formatting. So let's refactor our, let's hot swap. And the moment this should be done, this shouldn't be sending this anymore, it will be sending, yeah, exactly what we need. So this we can just copy out of the console. Let's copy that. And then let's go down here. And let's go up here and let's just put this here. Because we want to know how it looks. So what we can check for now is just a simple check. We can check. We will set the string equal to text.getString, and then if string.starts with this thing, this part of the CPU usage. Let's do if it doesn't start with that. We can just return event result.pass again. let's move this. And now what we can do is we can set a substring to the string of that. This autocompleted stuff isn't what we want. We want to set it to the substring after this string, and we want to cut off the remaining thing, the percentage we can keep. We can also remove that just for the sake of it. So we want to trim it until the length -3. I believe this should be correct. It might be length -2. Let's see. So let's just S out the substring. Let's hot swap it again. Yeah, my bad. We need to actually do -2 because we want to cut off the last 2 characters. So now, see, it just prints out the percentage, which is the percentage that gets displayed on our action bar right there. So we're basically done now. We just need to render this to up here. So let's make and for this we will need to restart. Let's make a private string usage. Let's initialize this to an empty string. Although I think this, yeah, no, okay. So we want to instead of rendering hello world, we want to render CPU usage. So this will render even if usage is empty. So let's do an if usage.is empty. We will just simply return. So here we will then set usage equals substring. And what we can also do, but we'll do that in a second, let's first restart. The problem with this is, if you now get a CPU usage displayed once, and then you go to a different plot, it will continue displaying that even if you're not actually getting any action bar. So what we can do in a second is we can add a simple timeout to this so that it stops displaying if it hasn't gotten a action bar packet in a little bit. But let's test this first. For that, we'll go to my testing plot that I made for this. We'll wait for the pop-up to disappear. And look at that. That's our CPU usage. Let's add a percentage sign to it. And there it is. We could add some coloring to that and stuff, and we can do that in a second. But let's start by looking, because now if I go to spawn, it will still display, and we'll keep doing that forever. So let's add a second private variable, private long, which is just a big number, last update. And then instead of checking this here, we're going to check if system.current time milliseconds minus the last update. Actually no, we'll do display until. So what we can do is if current time is bigger than display until, we return. And when we get one of these updates here, we can set display until to be the current time plus 1 second. Because this is in milliseconds, we have to do 1000. Now we'll have to restart again. Let's remove this printout. So now, if we restart once more, this will display the text. But once 1 second has passed and you haven't gotten another action bar, it will stop displaying the text, which is exactly what we want. So let's go into DiamondFire. And let's join the plot. Let's wait for the stupid pop-up to disappear. And voila, it shows the percentage. But now it sometimes flickers, because it takes more than a second to receive the packet. So what we can do, to receive the next packet, so what we can do is we can increase the timeout to 3 seconds. And now it should be fine. Now let's go to spawn. And it'll disappear. If we go back to the plot, it will reappear. Isn't that great? Now let's do one more thing. instead of checking a simple starts with, we can do something cooler, something better. We can set up a private pattern. This is gonna be a final pattern, a private static final pattern, CPU pattern, or CPU regex. This will be a pattern.compile. And let's for now just put this here. Now, if you don't know regex, this might be a little confusing to you. But essentially what we want to do is we want to match this literal string. We do this backslash because this bracket usually has a meaning in regex, so we have to escape it so that it's just a normal bracket. And then we want to capture this. Now, these brackets also usually have a meaning, so let's also escape these. And then let's add more brackets around this. And let's give them a name. I believe it's something like doing usage. So now this capture group should have a name called usage. So now we can do, well actually we don't even need a name for the usage, we can just do it in brackets. So now what we can do is we can do on packet, instead of checking if starts with, we'll make a matcher, and we'll match this input string. We can just put that right here. Then we'll check if matcher.find, if matcher doesn't find, result event pass, return event pass. And if it does find something, instead of doing a substring, we can do matcher.group, and then we can do the first group. I'm not sure if this will be 1 or 0. Let's quickly figure that out. Yeah, we'll do group of 1, because group 0 would be in the entire pattern. So this should do the same thing, but now it also checks if there's a bracket after, and it gets the percentage right out there. We don't have to do any substring stuff. Let's start Minecraft and see if it works. One final thing we can do after this is we can add we can return event result cancel so that the action bar doesn't get filled up by the actual action bar thing anymore. And we'll do that after testing this. Let's wait a moment for the pop-up to disappear. It doesn't work. Let's figure out why. Oh yeah, very simple. In here we just put numbers. We don't want to just match numbers, we want to match digits. No, I don't know. Oh yeah, you need to do double slashes because we're in a string. And we do this double slash so that this dot only matches a dot instead of anything at once, because that's what a dot usually does. So now we have to restart one more time. And we'll have to wait for the stupid pop-up one more time, of course, as always. Let's wait a moment. Look at that. It now shows 2 percentages because we wrapped this here. We can change that by wrapping it here, so when we restart this will be fixed. But now instead of returning a pass, we can return a cancel. Now we do have to restart one more time because we changed this as well. But now this should make it so specifically when you get something that matches this matcher, this thing over here, it will not display in the action bar, and we will just see our cool display version of it. So let's see if that's true. After we wait for the stupid long pop-up here to go away. Look at that, and there's no action bar here. If we now go to spawn, it will disappear. And yeah, and this action bar works, so it doesn't just eat up every action bar. Now that should be it for today, but let's real quick just not add formatting, because this is kind of ugly, right? So let's do something like this, where we can okay, so this way now we have the two strings separate. So we have the CPU usage string and we have this usage percentage string. So let's do dot with color Flint. I think it's just called color. Never mind. Let's just go with 0x and let's do a nice red. And then for the actual thing, let's do a lighter red. And let's go with code changed. Let's go into this plot again. And look at that, now it has colors. These colors are in hex format, which means the first two letters are red, then green, then blue. You can look that up online. The 0x just denotes that it's a hex number. And yeah, this will be it for today. I hope you had fun creating your own Layer display. And I'll see you again in the next episode. Bye!